This video is for Chapter 11, Section 4, and it's all about the volume of prisms and cylinders. Previously, we looked at the surface area of prisms and cylinders, but now that we are working with three-dimensional figures, we're going to look at volume. Volume being the amount of space, cubic units. And a cubic unit is 1 foot wide, 1 foot long, and 1 foot high. That's 1 cubic foot, whatever the unit may be. We're going to find out how many of those little cubes fit inside a three-dimensional figure. So, it turns out we're not going to spend a lot of time deriving where the volumes formula, where they come from. We can spend some time on that in class if we want to, but this video is just to say, what are these volume formulas that anyone could look up? And then we have to know how to use them. That information's out there for us. So, the volume of a prism, turns out we're going to take the area of the base. Now remember, a prism has a base and a height. And that base is a shape. And if that shape is this rectangle, we're going to take the area of that rectangle and multiply it by the height, which is essentially how many rectangles there are. So we have the area of the base, that's why it's a capital B, times the height of the prism, which has to be the perpendicular distance between the bases. This is a pretty simple formula for us. As long as we can figure out the area of the base, multiply by the height, and we're done. Then there's the volume of a cylinder. Well, this has the exact same formula, area of base times height, except for the area of the base is replaced with pi r squared, because the base is a circle. So, pi r squared times height, height being the height of the cylinder. Let's take a look at how this works. I have two shapes. One, a triangle-based prism, and a cylinder. Again, take a moment to realize that 12 by 20 rectangle is not the base of this shape. The base must be the two congruent parallel parts, the triangle and the triangle. 20 is the height. So, volume of a prism, we've identified a prism. Maybe we shade in the bases to know that they are the bases. And we can say here, here's what I know. H is equal to 20. All I need is capital B. Well, again, this is a level 3 test question. How do I find the area of an equilateral triangle? We've done this multiple times. I take the base of 12 and I cut it in half to 6 and 6 with an altitude. And because this is an equilateral triangle, 60, 60, 60, it becomes 30, 60, 90. And now the height of the triangle, not the height of the prism, the height of the triangular base is 6 radical 3. So my capital B is 1/2 base, which is 12. A lot of you are still missing this. The base is not 6, it's 12. Times the height of the triangle, 6 rad 3. This becomes 6 times 6, which is 36 rad 3. Now I can say volume equals area of base, substitution, times 20, another substitution. 36 times 20 is 720. We put on the radical 3. This is the exact area. Again, we go to the calculator for the decimal area. 720, radical 3. Area of base times height. And that was a tougher problem. The rectangle ones are easy. Now how about cylinder? Well, cylinder's formula is just pi r squared times height. We have to recognize that if we know this formula, all we need are two things, the radius and the height. Well, the radius, if the diameter is 10, the radius is 5. And the height is already given to us as being 15. So this is literally just plug and chug. Plug in the numbers and make it go. Volume or the base equals pi times 5 squared, pi r squared, 25 pi. And then the volume is just that 25 pi, pi r squared, times 15. Just like the radical 3, I'm going to ignore the pi and do 25 times 15, which is 375 pi. This is the exact answer. Now, you go to the calculator to find the decimal answer. given that this is pretty short, I'm going to look at a real quick challenge problem. Not going to spend much time on it, but check this out. What if we put together the two lessons? Find the volume of a cylinder with height 8 and a surface area of 40 pi. So I got to find volume. I have height, but I don't have R. But I do have the surface area, which comes from this formula. 2 pi r times height, remember that formula, plus 2 bases. Well, they tell me 40, so I'm going to substitute 40 pi. 2 pi r, here's h, I plug it in. And this is an interesting problem. It becomes 40 pi equals 16 pi r plus 2 pi r squared. I'm going to divide all parts by pi. Divide by pi. Pi is gone. 40, 16r, 2r squared. Back in algebra, we were taught how to solve these type of problems using factoring. That's why this is a challenge problem, just for you to look at. So I bring everything over, subtract 40, set it equal to 0. I reduce out the 2 by dividing everything by 2, and 0 divided by 2 is still 0. And then I can factor. 0 equals r plus 10, r minus 2, which gives me two solutions, equals negative 10 or 2. Well, the radius can't be negative 10. This is geometry. We can't have a negative radius. So our only possible answer is r equals 2. Huh? Now we're ready to find volume. Pi, radius, which was 2, squared, times 8. 2 squared is 4. 4 times 8 is 32. 32 pi. I thought this would be a good challenge problem to have in your notes because it represents something you might be able to earn extra credit on the quizzes and tests about volume and surface area of prisms and cylinders. That's it for Chapter 11, Section 4, Volume of Cylinders and Prisms.